I'm Anil Kumar and we'll study characteristics of linear functions in this particular video. We'll consider horizontal and vertical lines. We already considered slanting lines in the previous video. Let me just make a correction here. Characteristics of linear, I'm writing here relations. Now there is a reason for this and we'll soon find what is the relation, right? So we are considering horizontal and vertical lines, and these are of course relations which we are talking about. You may figure out that one of them is not a function. So when we have a horizontal line, it could be like this, right? So it could be on the upper half or on the lower half of this quadrant. Now vertical lines could be on the left or right side. So we are assuming them to be on the positive side just to discuss it. Well, the characteristics remain the same. Okay. Now in these two lines, what do you notice? Which one is a function and which one is not a function? Now the very first one, for each value of x, as you can see here, we have unique value of y. So for every x we have a unique value of y. It could be same. Let us say this value is the y-intercept. Let us say this is at b. So the equation of this line is going to be y equals to b. In the second case, when we are talking about a vertical line, x value remains same. Let us say x-intercept is a. In that case, equation of the line is x equals to a. Now here, for one particular value a, we have so many values of y, and therefore this is not a function. So this relation is not a function. However, this relation is a function. And I hope now you understand why. I first wrote this as characteristics of linear functions, crossed that functions out, wrote as relations. You will never forget now, right? You'll remember that linear relations could be functions and may not be functions. Vertical lines are not functions, correct? So that is one thing which we understand. Now let's get back to the characteristics. Characteristics for horizontal and vertical lines are very different from the slanting lines. Here, what do you notice? Here, in this case, domain is what? X belongs to real numbers. How about the domain in this case? Domain here is that x is equals to just a, right? Not all real numbers. As far as the range is concerned, range in this particular case is that y value is only b, right? So y is equals to b, just one value. However, range for a vertical line is all real numbers, right? So that is a huge difference between slanting and horizontal vertical lines. Okay, x and y intercepts. So you notice here that as far as the x-intercept is concerned, we have none, right? So we do not have, so no x-intercept. And here x-intercept is at x equals to a. As far as the y-intercept is concerned, there is one y-intercept which is at y equals to b, and in this particular case there is no y-intercept, right? So none, right? So let's say none or no y-intercept, correct? So that is one thing. Now how about positive and negative, right? So you see that this line, in this case, if the y-intercept b is greater than 0, in that case always positive, right? If b is less than 0, always negative. We'll take special case later, and now you get it. What is a special case? Special case here will be y equals to 0, and in this case a vertical line x equals to 0 will be a special case. So let me write here special case, which we'll consider later. Okay, so that has some exceptions and we'll do that later. Okay, So what we notice here is that this line is always positive if b is greater than 0, always negative if b is less than 0. And in this particular case, as far as the line above x-axis is positive, right? So here we have line, so we have positive line when which is above a, so positive above x-axis I should say, right? And negative below x-axis, right? Well, the point x equals to a is common. As you know, this is not a function, it's a relation. So that is how the characteristic is. Now, as far as the end behavior is concerned, the end behavior here in the first case is that as x approaches negative infinity, y approaches what? As x approaches positive infinity, y approaches what? Since y is always b, it is just b. It is in fact equal to b, right? So that is the kind of end behavior. Y is always b. In this particular case, we do not have the end behavior, right? So there is kind of no end behavior. Since x can have only one value, and that is the x-intercept, so it cannot have any end behavior. So that's the case, right? So strictly speaking, we should not be even talking about positive negative, because at a it could be positive or negative. You understand my point, right? So that is how we can look into it. Now the question for you is, how will these characteristics change if I have a special case where we're talking about x-axis and y-axis? So let me write y equals to 0. This is what we are trying to say is x-axis, right? And x equals to 0 is y-axis. So major change is that in these cases, let's begin with the horizontal line. We have infinite x-intercepts. So in this case, we have infinite x-intercepts. And in this case, we have infinite y-intercepts, okay? So that is a huge change between the two. So that is how we can actually look into these lines. And also, as far as negative and positive values go, you can see y is just 0. So there is no negative or positive value for the horizontal line, which is represented by the x-axis. So in short, what you gather from these videos is that linear relations may have very different characteristics depending on whether the lines are slanting, horizontal or vertical, and also whether the lines go through the origin or not. That is kind of very important to understand. So depending on the case, we have very different characteristics. Therefore, I'd like you to go through these videos once again and be clear in your mind about their characteristics. One aspect which I haven't discussed in these is about the symmetry. So let me talk about it now. You can see this line is symmetric about y-axis, right? This line is symmetric about y-axis. We also say this is even function. However, this line is symmetric about itself. This is symmetric about itself. What I'm trying to say by itself is this line is symmetric about y-axis. Do you see this y-axis? But here it is symmetric about the line, which is the line itself. So that is the kind of symmetry these lines have. The slanting lines do not have any symmetry until and unless they go through origin, right? So when we are talking about slanting lines, let me put it here. Slanting lines through origin have odd symmetry. I think we'll take up another video on symmetry also, so that these points are absolutely clear. But I hope with this short introduction on symmetry, you have understood how you can incorporate symmetry into characteristics of the line. I hope that helps. Thank you and all the best.